Hello everyone. Starting from this class, we will enter the practical application of ultrasonic testing. This part is the key content of the course for different workpieces and defects. Different ultrasonic testing methods and technologies should be applied. I hope everyone can study hard. This lesson is mainly about the production process of the plates and the common defect types. For the ultrasonic inspection of plates, firstly, we need to know the production process of plates and the common types of defects in them. In this way, it is possible to identify which defects may appear in plates we are about to inspect, so as to effectively identify the defects through the echo signal. In the production of steel products, at first, iron ore is smelted into molten iron, which is then smelted into steel. After 2 times of smelting, the molten steel was obtained. And the next step is to turn molten steel into steel products. The molten steel can be poured into the mold and let it solidify into an ingot. After that, the ingot is heated for various rolling as needed. Rolling is the most widely used process method. It mainly makes the steel pass between 2 rotating rollers. The temperature of the steel coordinates with the pressure, distance, and speed between the 2 rollers. And then different steel products can be rolled. It's kind of like the method of pressing the dough. The younger generation can only become talented by studying hard, striking while the iron is hot, and practice makes perfect. Firstly, the production process of the plate. The production process of the rolling mill can be divided into 2 types: hot rolled steel plates and cold rolled steel plates according to the rolling state of the rolling machine. Among them, the techniques of hot rolled medium plates, thick plates, and thin plates in metallurgical engineering are similar. In general, the main processes include raw material preparation, heating, rolling, hot state correction, cooling, floor inspection, finishing, by which slabs are transported from the blooming plant into the slab warehouse. Unloaded by the crane, slabs are stored in the warehouse and unloaded into the heat preservation furnace by the crane. After inspection and supplementary cleaning, the steel are put into the heat preservation furnace of rolling. During the production of metallurgical engineering, the steps are hoisted to the track individually by cranes, and then pushed into the furnace of heating before being transported to the heating furnace. There are 2 types of heating furnaces: continuous tap or flat section tap. The well-heated steps are transported from the outpipe track to the vertical scale breaker. To remove the primary scale, then let them enter the first and second rolling mills. Roll back and forth for 3 or 5 passes, and then enter the third and fourth rolling mills of continuous rolling and roll them for 1 pass. During the rolling process, the iron oxide scale is washed away by a high-pressure water gun, and the thickness is generally rolled to 20 to 40 mm. Thickness and measurement, with measurement and temperature measurement, are carried out after 4th rolling. After that, they are sent to the front of the finishing mill by the roller channel. The shearing heat is firstly flowed, and then continuous rolling is carried out by the 4-roll tap finishing mill. After continuous rolling, the steel strips are cooled by laminar flow, and they enter the underground coiler to be rolled into hot-rolled steel coils. Thus, the rolling process is completed. The entire rolling process of the production line is fully automated. That is, starting from the feeding roller, track, heating furnace heating, rod milling, rolling, finish mill rolling, laminar cooling, cooling by coiler, to the purification point to the steel coil transportation chain, the entire production procedure. It is automatically controlled by the Process Control Computer (ACC) and 3 Digital Direct Control Computers (DDC). Plates are divided into ordinary plates and composite plates, among which ordinary plates are the most widely used in industry. In ultrasonic testing, according to the thickness, we can divide ordinary plates into thin plates and thick plates. The division is based on whether the thickness of the plate can excite plate waves in the plate during ultrasonic testing. When inspecting at normal incidence, because of the bland area of the instrument, it is impossible to distinguish the defect wave between the initial wave and the bottom wave for the plate below 6 mm. Therefore, the boundary line between thin and thick plates is set at 6 mm. A plate with a thickness of less than 6 mm is called a thin plate, and a plate with a thickness greater than or equal to 6 mm is called a medium or thick plate. To thick plates, the vertical inspection method is generally used, and to thin plates, the plate wave inspection method is generally used. Composite plate refers to a specific method to combine two different types of materials to form a new plate so as to obtain a special surface property. For example, to collide substances on carbon steel or low alloy steel substrates such as stainless steel, titanium copper alloy, or aluminum alloy, etc. To improve the corrosion resistance of the material, compound babbitt alloy on the bearing surface to enhance its wear resistance, etc. The combination between a composite layer and the base metal is commonly used by rolling method, exploding method, welding method, etc. Obviously, the strength of the opposite panel is mainly ensured by the parent material, and the composite layer is responsible for providing the special properties required. Second, the common defects in the sheet. Common defects in the sheet are delamination, inclusions, cracks, white spots, etc., of which there are few cracks. Defects in the sheet are mostly flat and parallel to the surface after rolling and other processes. Among them, delamination is the most common internal defect. Delamination is a local gap in the section of the steel plates, which makes a section of the steel plate from the local layer. It is a fatal defect in the steel, and the steel plate is not allowed to have delamination. Delamination, also known as interlayer, is an internal defect in steel. Air bubbles in the ingot, large non-metallic inclusions, residue scratch cavities that are completely removed for folds may all cause delamination of the steel, and unreasonable rolling may aggravate the delamination. In addition, the defects in the composite sheet are mainly the poor bonding between the composite layer and the base metal, and the phenomena of complete or incomplete separation at the interface. Therefore, for the ultrasonic testing of the sheet, the load on the sheet needs to be considered when the sheet is subjected to tensile stress parallel to the direction of the defect. The defect will not seriously affect the strength of the sheet. When the sheet is subjected to tensile stress that is perpendicular to the defect will seriously affect the strength of the sheet, and such a defect is not allowed in the sheet. In this lesson, we learn about the basic process of sheet production, the classification of sheets, and the common defects in sheets. For sheet ultrasonic testing, we need to consider the influence of the defect direction on the use of the sheet. Therefore, before ultrasonic testing, we should get a comprehensive understanding of the workpiece, such as considering the thickness of the plates, possible defects, the direction of the defects, etc., to select the appropriate inspection method and technology. Let's call it a day. See you next time.